Okay. All right. Hello there, everybody. Here's another video again, another live stream, and I'm here with Mrs. Genesis Gurr,
Hello.
and today we're going to be talking about uh, OpenCV, or better known as CV2 computer vision. Um, Today was Mother's Day. It's technically still Mother's Day. It's 11:41 p.m. right now. I just wanted to uh, go through and talk about some OpenCV2. I dabbled around, and I don't know if anyone saw me on Twitter dabbling around with this code earlier. Um, as it's called Waifu Detect. And now, why did I need to make two different programs for, or two different modules for detecting waifus and detecting real people? The two distinctions are that with the original um, program, just using the default detection model, machine learning model for face detection, it it detects human faces better than it does anime. So the one that I made, I specifically found a website. If we go over here, and we are streaming on YouTube, by the way, I'm gonna plug in my Twitter inside of the streams. I might just do that from now on because I want to, Twitter's really important, guys. I really post a lot of stuff on Twitter, like shit like this. Waifus are the secret to being semi good at programming. Trust. Yeah, I got a lot of stuff to share. I hope everyone had a great Mother's Day. Um, I myself had a great Mother's Day. I spent time with my girlfriend. Not as much as I wanted to because, she went to a barbecue. I went to a barbecue. It's like, yeah. But today, Mrs. Genesis has us. We have her. She's captured. So back to the programming world. How do you feel?
Amazing. It's better than being out of it, actually.
Yeah. Um, and I tweeted something here. Retweeted something. This is a quote by Albert Einstein. Um, Life is like riding a bicycle. To keep your balance, you must keep moving. Um, and then I wrote my own little quote here. I might actually end up doing these little quotes.
Hmm.
Science is a crucial part of our lives, but hope is even more important, right?
Hmm.
That I feel like that is really, really important. So, um, I'm not religious, but I'm not even going to say that I don't believe. I'm going to start changing as of, yesterday and this week. The next time a religious person comes to my stream, I'm going to just be like, I'm open to all possibilities. I cannot definitively say that nothing is impossible. Anything's impossible. And if you guys have no idea on the stuff I've been studying so far, most of you guys probably do not or don't have the ability, unfortunately, to discuss some stuff like this. Maybe it's because maybe your family doesn't allow you to, maybe you don't have access, or maybe you just don't look it up. But whatever the situation is, guys, I just recently started getting into, and we're gonna get into the machine learning aspect of the stream, right? But the face recognition. But I just want to share with you. Look at all this data. This is on. Let's see what vault I'm on. This is the.
Huh.
What vault is this? I don't know what vault this is. Okay, this is here. Let's go open one up. Astronomy. This is all the data on astronomy. Look how vast that is. String theory, wormhole definition, space time definition. Some of the things that I've been learning so far have been very, very interesting. you know, and it's just amazing. You learn so much stuff, and I haven't gotten the time to go read thoroughly through these things, but I do want to say if you guys are interested in astronomy, science, space, biology, acoustics, um, anything that has to do with science, dark matter, wormholes, physics, quasars, space, three-dimensional space, uh, physics, thermodynamics, all that stuff I'm going to be talking about on in my streams. And now, if that stuff isn't for you, that's fine. But if you're into computer science, some of this stuff does leak into coding. You're probably talking to a guy who's probably going to be creating his own computer out of scratch one day. Yep, I'm talking from scratch, from the microchips to everything. It is possible. It's been done before. Um, and, so in today's stream, we're not going to go on a tangent here, but we're going to be talking about computer vision. Now that I'm here, my love, do you know anything about what do you have an understanding of what computer vision is?
I don't
It's
know.
it's okay if you don't know. So, what computer vision is, OpenCV played a huge part in the Mars landing with object detection, video processing, image processing, image manipulation. That could be sharpening, brightening a video, and stuff like that. And tracking. Yes, that's right. You heard me right. Tracking. You can actually track with OpenCV. It's really cool. You can track objects and stuff. So today, that's what I've been working on, and as you can see, this is the first one. The first one that I'm going to show you guys. We're not going to code anything in the stream. We're going to mostly break things down. And we're going to start with this one. So here we have the first one that I made. CV2 stands for computer vision and is a third-party Python module that allows the ability to manipulate image, video data, and face recognition AI capabilities. In this module, we will use face AI recognition, object detection to identify the ages, gender. Not in this module. In this module, we're just going to detect faces. And this is the syntax. Pretty simple. And then I have something really cool to show you guys. This one, the HAR cascades are not capable of detecting, because the HAR cascade frontal face default.xml learning model algorithm can't really focus on animated faces. It's more so for real faces. That's how intense, that's how complex these models are. Here's something. Go on.
I forgot what I was gonna say.
Okay, here's a fun fact. Did you know that ChatGPT is a model itself? It's a model that works with a corpus of collections of text, and it's artificial intelligence. So what we're working right now with are just like models. We're working with models, but there's models for different types of things. And the models that we're working with today are face detection models. Well, they're more than just face detection, but we are going to stay in the field of face detection. So, before we go run through this code, I have 1, 2, 3, 4 images. We can delete this. I don't use this. The first one is an image of Charlie Sheen, right? You can tell. Second one is of Robbie. She played in Suicide Squad as Harley Quinn. We have a random image of a woman that we picked up from the internet. We have a Walter White image 2. So we have a total of 1, 2, 3, 4. What is our model? What is the horror cascades detection model going to do? The model is pre-trained defined faces. We have to write the code to make that work, right? So without further ado, we're going to see boom, 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 boom. Okay, so let's start off by trying to find Charlie Sheen's face.
Okay.
Now, I have something really cool to show you guys. So you're going to notice throughout this video that some of the images and the face detections are in black and white. There's a reason for that. I'm going to tell you the cool fact after we display this. Have you ever wondered why some military cameras, when they're chasing their enemy and their enemy's jet is in like plain black or it's plain white and the bullets look black or white and the whole screen, why don't they do colored? Why don't they use colored videos? I mean, some of them might, but like the precise jets, you know, you might see some jets like from like the Pentagon. They'll use straight up black and white webcam footage, and I'll actually show you this right now. If we go to YouTube, and I'm just gonna look up
Black and white.
no, we don't even have to. Let's see how military UFO fighter footage. That's because that's the only Pentagon footage that I could really find. You could see, look, black and white,
Oh.
black and white, black and white, black and white again, black and white, black and white, black and white. Look, even some
Cameras in
cameras in general are in black and white. Why is this? Well, I will tell you. If you're very interested in programming and you're really into this stuff, I'm gonna break it down for you. The reason why it's black and white. Okay, we're not gonna go click on those videos because of copyright, but we are going to continue. So let's go ahead. Look, boom.
Oh.
As you guys can tell, the image is in black and white. We coded it, so we filtered the image to be in a grayscale. And grayscale means to remove all the RGBA values. So all the colors from the picture. And as you can see, this black borderline around. And to prove you guys that I know what I'm talking about, just in case I don't want to mislead anybody, we're going to make the border of the rectangle a little bit thicker with this. So we're going to put 10. It was 2 before, now it's going to be thicker. Look at this. See that? So it's now thicker. So it's a little bit more, you know, if you want that, and you're able to actually make this border any color you like. You can make it white if you wanted to. We could even, like, some of the borders that they're using here, they have like a white border here, you know, and that's programmed. And even this right here, that's all programmed. All that, you know, everything you see inside of this webcam is programmed. But now for the secret, I'm going to do another image. We're going to copy the path of the image. Don't worry about the code right now. I'm going to break that down for you guys. And let's try Robbie. Now, maybe some skeptics out there are saying, nah, it's a picture with the already rendered on there. Pay attention to this image here. It does not have anything. All we're simply doing, for all my programmers who know how to code out there, take a good look at this code and tell me if we are loading some image that it's not. The path to this image that we just clicked, it's right here. I clicked on it. Robbie.png. So scrapyard. This image, the Robbie.png, is in the scrapyard. Yep, we're in there. Right there. Boom. Lab sketches February 2023. Yep, we're in there. Deep face sketches. Yep, we're in there. Images. Yep, we're in there. And there it is. Boom.
Oh,
Does not have a square. So let's see what happens. Can this model detect her face? It can. And it's not over here this time. It's over here this time.
oh,
So what does this mean in this scheme? Why would you even want this? You guys want to make robots? You guys want to actually make robots that are very intelligent and can detect shit? This is how you do it in Python, you know? Um, you guys want to um, just, set this up, make a program for your web camera and have a live stream up and detect faces. And then maybe actually, this is a scary part. Here's the scary part. You could actually screenshot. You can make your program automatically screenshot these faces and put them in a folder. Yup. That's pretty cool stuff, right? Now, for the secret. I wanted to tell you guys the reason why why do you see most web cameras that have to do with security or the military have to be in black and white? When you operate on a black and white plane field or dimension, or more so a field, you are operating on one field. For that model only has to interact in one field, and that field is intensity. An intensity in the fact of black and white. What does this mean? If the military were to use colors in this video, in their, their footage or their stream, their detect object detection model would have to process more pixels, more colors, and it does matter in the sense of object detection because every little bit, and I'm going to prove it to you guys now, that detecting a video in black and white is way better if you're trying to detect things than things that are in color. Now, there probably are programs that can have really good algorithms and really good things done together. Like it could, it's capable of doing it. But, in the grand scheme, black and white is better because we're working on one field, which is intensity. And the detection program can detect the shapes better. Does that make sense? Can make out the shapes of whatever it's trying to detect better. You know,
yeah.
what's easier more to detect? If I, was an model detection, I told you to detect the face. It's going to start right here or wherever it's going to detect, and it's going to scan all these little dark, these colors individually. It's going to look. Maybe it might accidentally detect this as a face, or maybe the door. Maybe they'll think these are two eyes and this is the mouth, maybe.
Maybe.
You know,
Or the Ava in the back.
or this, this is technically not even a face, but to believe it or not, this is still a face. It would still detect this.
Yeah, it's
You
just
know,
Unit 2 has 4 eyes.
yeah, it goes through these algorithms. Now, if all this was in black and white, it's gonna skip all over the bullshit and it's gonna look for, oh, okay, yeah, that's a face. That's a face. Boom. And that's how that works. So now that I've shown you the reason, what do you think about that? What do you think about that? I'm talking to you, Mrs. Genesis.
I'm smiling right now. I'm so amazed by this. What's it called?
Mm-hmm, mm-hmm.
When I look at your code, it's like it's really short, and before you even learn how to do this, it's like I don't even know how to do this, but before you learn or see how to do this, you'd think it would be
Some massive amount of code, right?
like a whole GitHub repository.
Nope. And that's where most people get misconstrued, you know? Some people be like, oh, well, code has to be long. No. And maybe someone else might have written this a little bit longer. All of this could probably be written 10 times better. This is freestyled code. And you know who you are. If you're watching this, you probably could have shortened this code even more shorter. Because, companies do not want, what is it? Oh, hello. Like the movies. Oh, yeah, welcome to my stream. And guys, I want to apologize. I apologize to you guys who have messaged and I haven't seen your messages yet. This app does not seem to want to give me messages. But welcome everyone to my stream. I'm Genesis, and you guys can find me on Twitter. Just look for the guy Finn Wolfhard. This is my, the guy from Stranger Things. Yeah, at this point. I look at the whole coding community in science as Stranger Things. Guys, we live in a real life Stranger Things. Because if you knew the things that I study, man, did you know a black hole? I'm going on tangents. We'll save that for another stream. Black holes are fucking crazy, okay? We're not even going to get into black holes and how they work. But a black hole has 3 parts. What is a black hole? It's a hole in space and time. Did you know this? Black holes are the product of stars dying. When a star dies and its fuel runs out, it turns itself into a black hole and it eats itself. So imagine if you died, you turned into a little hole that devours anything that comes near you and you swallow it to an oblivion. That's how cool yeah, it's amazing.
It's a little confusing as well, so
Yeah.
I'm trying to think, cause
I'm going to open up Chatty here so this way I can get messages more clear.
yeah, cause Chatty will give you notifications, but
Yeah, Chatty will give go on.
I'm curious about if when stars die, like, and they create like a black hole, like how big will the black hole be when it starts out?
Oh
Like,
my god. Check this out. Stars are massive and they're balls of hot gas and other things. And when that fuel, that gas runs out, it's almost like it's life force. It'll collapse itself into it will become a black hole. And you know how many black holes are inside of space? Hundreds of millions of black holes. Again, we're not going to go on a tangent, but if you guys want to hear more stuff about that, I'll definitely get into it. But we will get back into this. So yeah, Waifu face detection period. Why do some cameras or security cameras are in black and white? Because it's easier, long story short, it's easier to detect things. It makes the detection, it makes the machine learning pre-trained model detect things faster. It doesn't matter what that program was programmed to actually detect, whether it be a human face, a person running across a field. You'll see this military will actually, detect people walking across and you'll be like, oh, why are they white little dots or white little human beings? Because it's easier to detect a white little dot human shape than a colored human shape running across the field. Does that make sense? So that's deadly. Okay? Really think about this. Now, I'm going to give you guys a nightmare tonight. Imagine if artificial intelligence, deeper down the future, use this for bad. Yeah. Right? Really scary, right? We already have the capabilities of detecting human beings and shit, That's why a lot of people are very worried about artificial intelligence coming to a physical form, because if they're able to program themselves. Did you know that? I'm going on too
It's
many
good.
tangents. Let's
It's gonna be like a Chappie situation.
yeah, it's gonna be worse than a choppy situation. You guys do not want physical artificial intelligence present. You just don't. Trust me. They're unreliable. They're smart, but for their own good. Too much for their own good. It's better if we have a control on that situation. Why you love that video talk about the future universe? Oh yeah, definitely. Poflo, save that video, DM it to me on Twitter. I'm not able to actually watch other YouTube videos in like a YouTube video because of copyright. Yeah, I don't want to get copyright strike, but that's why I'm gonna have exclusive streams that we could all sit down and watch. So you guys will know the exclusive streams will say on the title exclusive streams, Twitch stream. And there I'm not recording. We could do anything we want, listen to any type of music we want. But yeah, but back to the topic. So, face detection, pre-trained machine learning model algorithms. They are amazing. They allow us to detect faces in images and videos. What could you do with this ultimately? You could ultimately, let's close this, put in a we have images, but in the future we're going to work with video. Yup. Your boy, we are going to go to, I don't know, doesn't matter what the source is. We can go to someone else's live stream. We won't do that. We'll go I don't know, download a video of like people walking in a city. And it will put these little squares, these little red squares on each and every individual person's face.
Oh,
It might miss some. It's not completely reliant. Let me let you
it'll
guys know
look for
that. Yeah.
it'll mark the ones that it notices and sees, right?
Yeah. And this stream is not to. You see Cyberpunk on Netflix? No, I've never seen it yet. I don't know. I've never seen Cyberpunk on Netflix yet. I've heard of Cyberpunk. Are you talking about the game?
No, the anime.
Oh, the anime. No, I haven't watched that yet. But yeah, that anime, never heard of it. Sounds good though. Yeah, let's get to the what you guys really came here for, right? The waifu face detection. Who cares about real faces of women or, you know, guys or Walter White? We want to actually detect faces of anime chicks, right? If you want to. Because you can't do that with this. You're like, oh, well, that makes it more stupid. No. Are you telling me that a model knows if something is not a human and if it is? That's creepy. If anything, that's a good thing, you know? And,
Yeah.
you know, would you want to, like, if I put up a picture of a face, all right, let's say if I was walking in front of a camera that has face detection and I put up a poster of someone else's face, it'll know that that's not even a real person because it goes off the dimension, the three-dimensional features and contours of your face. It's insane. Okay? But with that said, we're going to close this out.
Oh my god.
What?
No, I'm thinking about my phone right now.
What? Is it about to die?
No, because iPhones have face recognition, so now I'm scared.
Yeah, can detect other parameters. Like what? Before we continue, guys, ask me all the questions that you have. I'll ask any questions on OpenCV, and I'll tell you if it's possible. The next thing we're gonna do now, we're going to open up Waifu Detect. I wrote this program. Really quick program. It's not a full. It's not like, you know, a whole project. It is just something that. This is my first time working with this model algorithm, right? So how I work, I'm like we are all like artificial intelligence. We might fail. It's okay to fail, actually, guys. If you do not successfully do something, even artificial intelligence has to fail 50 million times to get something correct. We
To
can see
learn.
this in, excuse me?
No, I said to learn.
Yeah, to learn. So guys, how do you think AI learns? How do you think you learn? You learn by doing it over and over and over again. The only difference is humans have a limit. We could only learn so much, right? We don't really have a limit. Some people say we do, but I mean as in how fast we can process data. Everyone has technically a limit. No one in planet Earth can process data and computate data like an artificial intelligence. It's impossible. As fast as one, because it constantly just, it's super fast. It's impossible. Okay, we're not even going to discuss that. But what do you mean by parameters, Poflo? Make sure. Can detect other parameters. Like, what do you mean? And don't be afraid to ask. There is no such thing as dumb questions. It does not exist. I'm not a believer on people with dumb questions. Okay. Well, while he thinks about his answer, he'll eventually let us know. Let's get into this. So, if you're squeamish on anime girls, look away now. We're going to, obviously, you guys know how I code. I have waifus always in my background. Here we have a folder called Waifu Detect. Inside, we have a folder called Detection Model. This is the detection model that we're going to use. I'm actually going to link you guys. This is actually free. You can go download it and go fuck with it yourself. I got you. So here's the code of what it looks like. It's called LBP Cascade Anime Face.xml. This is a detection anime face detection model. It's been revamped by someone that I found. And look, I don't know what language it is. It's in it like an XML file. Looks interesting. I've never really looked into it. This is my first time. Yeah, a lot of leaf values. A lot of leaf values. So you guys know what that is. And over here, we have the image sources that we're going to be detecting for faces. So the first one, just the girl sitting down and holding a bag of chips or a book.
It's a book.
I saw a YouTuber who did a simulated survival with AI. Yeah, there's a lot of stuff. And guys, you guys are able to do this stuff too. It didn't take me this long to write this program that I'm about to show you guys. Here's one. The next one is suggestive. It's a waifu cowgirl, okay? Now, the next one after this is this one here. We got a bunch of waifus sitting here. 1, 2, 3, with multiple faces going on, right? So let's scroll up. Right? Will it detect this face? I don't know. Will it detect this one? We'll see. I wanted to get a big variety of different types of pictures. So we have a picture of 2 waifus covering their face right here. I wanted to see if the face detection can actually detect it. So you guys are going to be really surprised about this one. More so surprised. We have one with doing, different tasks, doing different things. But can you change the parameters? If you mean, can you change the parameters? Yes, you can. You have the ability to change how small the detection range is so it can find faces more concisely. And yes, you are actually able to change everything when it comes to these models, from how small the range is to how big the range is. But they are faces at that legs. Yes, you can do that. If you program that in. If you program that in, then you actually will be able to detect a leg if you wanted to. If you wanted a leg model, okay, I want to detect legs. You could. You want to detect shoes? You could. You want to detect hands? You can. You want to detect the ball? You can. You want to detect just the mouth? You can. But yeah. So yeah, so we have 1, 2, 3, 4, and 5 images. Okay, we're going to go inside of the main program now, which is called waifu.py, and we're going to go through this right now. Okay,
Okay.
so here's the code. A little bit longer than the last one. Not really. 91 lines of code. Not long at all. I mean, if you really want to break down these stages, we got one function. Take a good look at this. We're importing CV2, os.path. We're not even using os.path. We're not even using sys, I think. I'm not sure. No. We're not even using this. So we're going to take that out. We don't even have to use this, but I put it there because that's just convention. I'm not going to break it down. Let's run the file.
Okay.
Here we go. Okay, here's the first one. What do you guys notice?
It's not like it didn't catch anything. It wasn't able to detect the face.
It didn't catch anything. That means that this stream is not a hype up for face detection and model detection. I want to give you guys the honest truth of what goes on, you know? I don't want to be like, oh, guys, this is the best thing ever. As you guys can see, it can be wrong sometimes. It can't detect these faces. Why? And I came up with a reason why. It's missing an eye. I think the way it works off of an algorithm. It has to have these set conditions. It needs to have 2 eyes, 2 eyebrows, believe it or not, a nose, and a mouth.
Oh wait.
And as you guys can see, in both of these pictures, in all of these people, they're missing one of these components. So it can't even, find it. Now, this model that I got, this detection model, was like free. It was free. Most of them are free. All of them are free, actually, believe it or not. That I know of so far. So let's put that away. Okay. And I programmed this program to return the grayscale and the colored scale. I pressed the key on my keyboard and then moved on to the next one. So here's the actual one. It didn't even detect with colors. Okay. Not so impressive. But if they... Yeah. Yeah. It depends on the model, right? If it's a potato face recognition model, then yeah. You won't be able to trick a like real human detection model. Does that make sense? Each model is designed to find exactly whatever it is. So if it's an apple juice or if it's an object model, then it will do that. Hopefully that makes sense. Yeah, mouth on a potato. Yeah, Mr. Potato Head. Yeah, I get that one. So now we're going to go to the chill waifu one. Let's copy this one. Copy the relational path. I'm copying the path because we have to pass the path to the actual image path here in order to get this to work. Okay, here we go. Ready? I'm going to tease you guys the code. I know you guys want to look at the code, okay? We're going to get to that. Okay, we found something. Great. It found a face, as you guys can see right here. We found one. Now, remember this. If you're going to learn anything in this stream, it is easier. Using black and white images makes it easier to process and detect whatever you're trying to detect. Whether it be a UFO, for that, a UFO detection modeler, whatever, or an anime face modeler, using grayscale makes it easier for that model to detect whatever it's trying to detect. All right, let's go move on. Yep, and as you can see, this time we're using red because I made it so that it's red. Cool, right?
Mm-hmm.
Put Valorant, if there is one. I'll put Voldemort. I like detector. Put a Voldemort detector. Well, you could just use a normal like I guess a 3D CGI animated face detection. And
How?
what if I told you that this can't just detect faces? Some models can detect whole bodies. Yeah, your whole body. That's right. Or there's some models that can detect multiple components at once. Your face, your hands, all at once. It's scary. Now, close that out. Let's move on to the one that you guys probably want to look at, which is this one. And we're going to copy the relational path. I chose this one. Why? Because one, you guys already know.
Yeah.
You guys already know. And two, no, because there's a lot of colors and patterns, and there's black and white in her outfit, as you guys can tell. So I wanted to see if that would, confuse it. So let's go see if it does or not. Let's continue and run it. Yup. It detected her face right there. As you can see, there's the square right there. Yeah, color sure. And then let's move on to the colored version. It detected her face. Yeah, guys, we get it. I'm the perverted programmer. That kind of makes me original though, but I'm mostly perverted for my girlfriend. Let me say that. Now we can move on to the one that you guys have been probably really curious about. This one. Will it detect all these faces? Let's see. Furry boy. Oh god, I hope not. What, do you think I'm a furry boy, my love? Are you dating a furry boy?
Oh, you're not a furry.
No. Yeah, I guess it gets me misconstrued. I guess because of the ears. I guess some people think that I'm a furry, but guys, I'm not. I just think the ears look cool, yo. All right, let's see. All right, so now we're going to try to detect faces within this image here. And after we do this, I'm going to break down line by line, so pay attention. Now is the time to take notes down, and I'm going to show you guys how you guys can do this yourself. There we go. And we have 1, 2, 3. But look, we're not able to actually get these two faces over here. My loves, can you tell me why these two other ones have not been collected?
Cause one, the one all the way to the very right, part of her eyes cover it up, and it most likely doesn't detect that.
Yeah, correct.
And the one to the left, you only see one eye. You really don't see anything other than that, though.
Exactly. And you know how these face detection models work? They need to have all of the components or all the features of a face in full. Which is, there's probably better ones, but as you guys can see, all right, now we're going to click a key. What is this? You guys see the difference? We have captured this for some reason. It was incorrect. Obviously, this is not a face. You guys know what that is. Obviously. But the face detection in colored mode, let's play that again. Let's play this again. Yeah, funny, isn't it? Look, it's not there. Look. No block, no box here. Over here, it thinks that her behind is a face. Obviously, it's not. So,
Yeah, it's because of those highlights on her skirt.
I don't
Yeah,
know. I don't even see a face here.
it's the
I
highlights, my
the
love.
highlights, you think?
It most likely thinks the highlights on her
Povlo says
skirt.
no. You say yes. I
Huh?
honestly, I don't see a face there though. The highlights.
The highlights are the eyes. The
Oh yeah,
the stockings is the
the
oh my
smile. You
god,
think?
the smile. Yes,
And
my
then
love.
this right here probably looks like a nose, maybe whatever it may be. Um, this should be big proof to you guys that you should always, if you're going to do object detection, if you want to get a cleaner result, black and white. Convert your images to black and white. And you don't have to do this beforehand. You can actually convert your images in real time while you're programming. I actually converted, we're converting, Python is converting these images in real time. Well, not in real time, but it processes it, if that makes sense. It filters it in black and white. So with all that said, I think we can go through that. That's it. I'm going to go through the code. We're going to break down, what do you guys want to see? You guys want me to break down the Waifu one or the original one? The one with the normal faces. What do you want to see, Poflo? You want me to break down the Waifu one or the human one? What do you want to see, my love? Your vote counts too.
I'm not sure. Actually.
Voldemort Waifu. Okay, one for Waifu. The Waifu one is more complex, and
let's look at that one.
You'll probably learn more. Okay, great. So here we are. Let's see, blah, blah, blah. So I'm going to read this up here, and then we'll continue. CV2 stands for Computer Vision and is a third-party Python module that allows the ability to manipulate image and video data and face recognition AI capabilities. In this module, we will use face AI recognition, object detection, and we will do that in another stream. Whenever we do, we can identify ages, gender, ethnicity, so much more with just this. Can you imagine this? This is one module called CV2, and it's capable of all these things. And okay, so over here. So the first thing that I started off with, obviously, in order to work with CV2, you import with CV2. From here, we're doing from typing import type. I do this because we're using one function here, right? You don't have to do this. You don't have to return the type, but you should get inside of that convention. You should get inside of the habit of actually returning what a function returns. Why? Because if you're working with somebody and they look at your function, sometimes you might run into errors if you're programming with that person. And being like, oh, okay, this function returns a string, an integer, a float, or whatever, right? So having this here is convention. You guys should get into the habit of doing that. And the way you guys do that is with this import statement here. From typing, import type. Now, we got that down. Here comes the important part. What is a cascade file? A cascade file is the actual model, the algorithm that you're going to be using to be detecting whatever you want to detect. So, the first thing I knew, I wanted to make a Waifu detection, face detection. So I named the variable anime cascade file. This is the path to that file. And here's the path to the actual file, to the model file. And remember, guys, over here in detection model, I made a folder and I put it in there just to keep things nice and tidy and neat. No need. You don't really have to put a folder there, but it is convention. I even asked ChatGPT, it is convention to actually name your folder detection underscore model. Name it whatever you want. It's up to you. But, yeah. Oh, welcome back. But this is what this part is doing. Line 44, we are storing the path to the detection model. On line 47, we are creating the function called Waifu face detect. It has two parameters. The first parameter is the file name, which contains anime cascade file. The second parameter is the image color that we want to use, and the default image color is set to 0, and that's gray. On line 52, I'm importing CV2 to use it within the local scope of this function.
My loves.
Yes.
I have to go.
Okay. All right. I'll catch you later. Okay.
All right, my loves.
All right. I love you.
I love you too. Deep deeps.
All right. Deep deeps. Okay. Okay. Let's close this. Unfortunately, Mrs. Genesis had to go. But we're still gonna break this down really quick. She has to go. Now on line 57. No, on line 55, we are making the gray variable global. Why? We're making it global because we want to use this variable in the global scope of the actual module. And this is really hard. I'm trying to concentrate right now. Yeah, try to concentrate, guys, right now. I'm gonna close this off real quick because I'll be right back. Hold on. I'll message her later. Fuck. Okay. On line 57, this is going to be the image path to the image we want to use. Okay? So far, we just made a function. We imported CV2. And now we're providing the image path. And as you guys saw, that I would go back over here and actually switch the data here to the different images, right? These images here. These all have different paths, right? So that's what this is here. I'm height. What do you for my pills? Oh yeah, because your pills. Poflo was sick, right? Yesterday you were sick. I was sick like 3 or 4 or 5 days ago, but I feel way better now. On line 60, this is me actually choosing the detection model. So we called this model is equal to CV2.cascade classifier. What is this right here? This is actually the step where you're actually storing the XML file or the detection model inside of the variable, because you're going to use this later. As you can see here on line 74, we actually use it there. So on line 60, all this is basically doing is we're just choosing the detection model that we want to use. Going on line 63, we're loading the image. We have to load the image into CV2 imread in order to actually process the image. So we have a variable called image is equal to this here. I'm not going to read it all, but I'm just going to explain what the line is. And the imread has two positional parameters, which is file name, which is the image path, which contains the path to the image that we want to use. And then we have flags, which is cv2.imread color. Okay. Now, line 64. I made a copy of the image in color. As you guys remember, when we run this code, we can see it in black, in white, or in color. I had to make a copy of the original image so we could do that. Remember that. And the way that I did that is with the image.copy. Image stores the actual image that has been, processed by CV2. Now we go down to line 67. These pills make me feel drugged. Oh my god. Yeah, dude, pills. It sucks, dude. Like, yeah, if I were you, to be honest, I would probably just try to drink as much soup as you can and get as much rest as you can. That's what I would do. And I apologize, Poflo, that I'm trying to chug through this. I'm trying because we're like recording. I'm like on a rat race. Um, yeah. So line 67. What line 67 is, we're actually converting the image, the original image. Well, not the original image. We're converting one of the versions of the images into gray scale, black and white. That's this process. This right here, this is the process of actually, this is all you need right here. Not even just this line. Line 67 is all you need to make a color, to make an image black and white. And CVT stands for convert color. For convert. And then obviously, see, and then this takes two positional arguments. The source, which is the material that you're going to use, which is the image again. And then the code, the type of way you're going to color it. And right here, we're using CV2, color underscore background to gray. Converts an image from one color to another. And then you guys are probably wondering, well, what's line 68? What is CV2 equalizer hist? Technically, this is brightening the contrast of the image. What does that mean? It's better. It's good to actually contrast your images and brighten it up because it just makes it more easier for the detection. Without this, you'd probably get a little bit less better results. So using equalize hist, the algorithm normalizes the brightness and increases the contrast of the image. That's all this does. This just brightens up the image and the contrast of the image. On line 71, we store the original image, the colored image, and the grayscaled image in an array called image types. Now you're probably thinking, oh, why'd I got to do that? Yeah, you want to return the grayscale and the colored image too, don't you? So that's why I put them both in there, because I do want to eventually use both. That's all. From here, now, the big stuff. This is actually the process of detecting the faces. This is how you detect the faces right here. You know, you still got, you could really see all this stuff behind here is just choosing the detection model. So here, we're going to break this down really fast. Setting the image path to the picture we want to use, choosing the detection model, that's step 2. Step 3, loading the image using CV2 I'm read, that's step 3. Step 4, this is optional. You don't have to do this, but it is good to do this if you want to get a better, cleaner result. Is to grayscale the image. That's step 4. And then you don't even have to do this part. We're going to skip this part. And here's step 5. Faces is equal to model.detect multiscale. And then we have image types. And as you guys can see, image color is in there. And then here's are the detector settings. Now, Poflo, you asked me earlier in the stream, you said, wait, but are you able to mess with the parameters of the model, of the detection model? Yes, you can, right here. From line 74 to line 78, the scale factor, I could see tweak with these settings and mess around with it. Just because I'm a really, I like to be on par with the things that I say. Let's go hover over this. Okay. Yeah, I'm not going to say this because I don't remember what this stuff does. All I know is that it's the ranges of how it detects things. The scale factor, this is the lowest setting though. 1.1 is the lowest you can go. I wish you can go a little bit lower, but you cannot. So the lower this scale factor is, the more faces it will find. You can actually bump this up to 5, and then it'll find less faces if that's what you're looking for. If you want to find more faces, put 1.1. You can't put 1.0. Doesn't allow that. This is probably like the hard-coded default setting. Minimum neighbors. I forgot what this does, but I do know if you put this lower as well, you'll have the chances of finding more faces too. And minimum size. I didn't have any luck with this. I don't know. I didn't really see much of a change. So, great. So guys, go ahead and pause the video in the future and go ahead and study this so far. Right. Now, how do you actually draw the rectangles on the faces? How do you actually get that to work? Well, I'm about to tell you. So, first things first, you have to make a for loop, and this for loop should have X, Y, W, and H. Now, let's break that down. Don't get confused. Don't get lost now. I know you guys are like, oh, X, Y, W, H. What the heck does that stand for? X stands for width. Y means height. If you guys look carefully here, we see X means W and W means width, how wide, right? So I want you to put your hands as wide as you can, like you're going to give someone a hug. That's the width. So X plus width and then Y plus height. Now I want you to put your hand like you're raising your hand for a teacher. That's the height. So Y plus H. And then the color of the border. So this is actually the creation and the position of where these rectangles will be, right? So let's actually close this. Let's close it. Let's open it. See? And you can make them thicker. Look, just like I said before, let's make them really thick. Let's make them 50. Let's make it really pronounced. Right? Really, really pronounced. As you guys can see, it's... Why the hell would you want to do that? I don't know. But it's just an example, right? As you guys can see, it's... So thickness means how thick the rectangle is. And you really would never want that. Two is just fine. 2 or 3. 2 or 3 is just fine. And the color is the color of the actual rectangle itself. Right here we have 00255. Right? All right. So now we know that. We're drawing the rectangles there. It's back. Okay, so now we actually have to display the image. So after you have chosen your image path, excuse me, Beta, give me one moment. All right, coming. Okay, we are back. I'm sorry. Had to go to my door. Okay. Nice. So let me break this down really quickly. We have one function that is containing all of the logic to detecting the waifu faces. We are importing CV2. Yep, that was my mom. We have the image path. The image path, remember, this is going to be the picture you want to use. Doesn't matter what it wants. Like if you want, this is waifus, okay? The things that I'm showing you right now, this is for anime girls, anime guys, anime anything. Anime people. It's not just anime girls, okay? So Yeah. So line 57 is where you would put the relational or the absolute path of the image you want to use. And on line 60, we're choosing the model, the detection model. And as you guys can see, we have the default. The default model is going to be the anime cascade file. And the anime cascade file is here on line 44. And this is the path to the cascade model. We're almost done. Boom. Boom. Try with the dog. Yeah, why not? Let's go ahead with an animal. The dog is that a dog? Is it a dog you mean? Let me close restream. Yeah, we can do that. Well, it will take like 5 seconds. Why not? Dog from Full Metal Alchemist. I can't spell. Okay, let's see if it can detect this face. Let's get a good one. Okay. This one? Let's see if it can detect both of these. Let's see. Save it. And we'll name this image. No? Send it to me on Twitter. Send it to me on Twitter. I got you, bro. Send me the image on Twitter. The sad one. Oh, okay. Oh, no, the sad one. Okay, let's see. This one? This one here? This one. Let's use more so, two. This one here, or... Yes. So this one specifically. Okay. We'll see if this one... See if it can detect the faces. Exactly. Okay. I haven't tried it out. We'll see. We'll see if it can detect it. We'll name it, Full Metal Dog. Okay, now we're going to go ahead and bring it inside of our repository. This is how we would do such. We're going to chuck it inside of image sources. And here it is. Here's the image. Let me close all this. And completely do that. All right, so here's our image, right? We copied it and we dragged and dropped it inside of our image folder. Our image sources right here contains all the images that we want to use. And we're going to copy the path. Boom. We're going to go back over here. Right here, line 57, remember. Copy and paste. Full Metal Alchemist dog.png. Let's see. No. As you can see, it was not able to detect. It did not detect a face here. You want me to tell you a story of that little dog? Yeah, go ahead. Why not? And then let's try it with color. Oh, obviously no. It's not able to detect anything. What is the story of this dog? And while he's telling me the story, I'm going to just break down the rest here. You guys know we image path, model, loading the image. We made an image copy so we could have a colored version. We grayscaled. We made an array with the gray and the colored image. And we're actually detecting the faces. And then we're drawing the rectangles on the image. And then right here from line 85 to line 89, we're displaying the images with detected waifu faces. And then, yeah. And then down here on these two lines over here, we're returning display waifu grayscaled and display waifu colored. You guys see that? So we're using the same function, but we're using, you see this image color? Remember that I talked about? So there's that. It's a chimera. The image of the girl with the puppy. Well, it's them, but combined by her father in an experiment. Ooh, that's scary. Yeah, I need to get into anime, man. I don't know why I don't get into anime. My girlfriend has been trying to get me into anime for like the longest. And I'm like, no. It sucks. It really does. Yeah, but after the stream, I'm probably going to play some League. More than likely. Probably play some League of Legends. Time? It's 12:51. Mother's Day is officially over. Feels bad, man. I'm actually gonna tweet that. Mother's Day is officially over. Yeah, you know, I feel like it really takes a lot of what's it called, Poflo? A lot of, I don't know what it is. I like anime waifu, like, you know, waifus and shit, but when it comes to like watching like a full ass series, I can't do it. I don't know why. I mean, I can. I've done it before. I've watched anime with my woman, but it's like fuck. Yeah, but this is completely broken down. We've broken down every aspect. I guess, you know, with the display images with detected waifu faces, the I'm show is going to actually display the image. Named window, we're just making it full screen here. I don't even think that even does anything, to be honest. I'll be honest with you guys. I don't even think that does anything. Let's see. Yeah, it doesn't do shit. The wait key function. User presses a key to close the window. So this right here, line 87, when you know, look, I'm going to press G or any letter on my keyboard, and it's going to close the image. See? That's what that wait key does. It waits infinitely for a key press to do, or you can make it close automatically. These are seconds. So let's say I want the image to close every 5 seconds. Oh, these must be milliseconds or something. Okay, so they go by milliseconds. The guy was wrong on YouTube. They are not seconds. These are milliseconds. I'm not pressing anything. Ready? Yeah. These are milliseconds. And if you set it to 0, it's infinite. So if you guys run into that error, that's probably why. And we're gonna set it to the big booby one. Because why not? That's what you guys are here for. The fucking topic. You know? And then yeah, that's it. That's how you detect anime hoes on fucking VS Code. Really cool, right? That's how you do it. Detect faces. And in the future, we might actually we will detect faces through video. Any questions? Poflo, any questions? Anything you want to see, Poflo, in the future? Because you are one of my #1 regulars. Is there anything that you want to learn in the future? Let me know. Or is there anything you're learning that I could learn? You know? Teach me some stuff. I'm not the only smart one. You're smart too, dude. And I think that concludes it for the stream, honestly. I think that's it. We broke down everything about this. Hopefully that helps out. Your boy's gonna head out now. I think that's it. I'm gonna wait to see if Poflo types anything. If not, then I'm going to end stream because I am tired. I am really tired right now. Put some music on. Mew. Mew. All right, Poplo. Here, let me. I can't click on these videos. It's so sad. We can't like I can't watch YouTube videos while I'm actually recording a YouTube video. I can't do it. I can get in trouble. But again, if you guys want to watch like YouTube videos with me, then head over to my Twitch and we can do all that stuff. All right, yo. I'm out. Poflo, I might stream again tonight. I'm not gonna lie. Maybe not. We'll see. But you take care of yourself. Oh, by the way, if you are watching this on YouTube, I want to thank everyone who has been watching. If you guys have learned something, go to the bed. It's late and you are tired. Yeah, I'm about to head out right now. Thank you for being concerned. Really appreciate that. So yeah, that's it. That's how you detect anime waifus in VS Code, and more cool stuff to come. Thank you. This is Genesis Gur out. Trans.